Morning, everybody. My name's Emma Suck. Hoping that everyone can see and hear us okay, and that you see a presentation on the screen. If not, please just pop us a note in the chat. I'm joined this morning by my colleagues, Ciara Kruger, who's our research lead. Morning, Daniel. Thank you. Dan Fish, who's our technical specialist, and we've also got Bailey Sievewright from the Electric Vehicle Council on the call, who's come along. He's been voluntold to come and give us a bit of a hand with the technology. We're new to webinars, so he's giving us a bit of a hand. Hi, Jerry. So while everybody's still kind of popping into the meeting, we'll get going. This morning we're going to run through, I guess, the supporting information to the Australian Building Code advisory notice about electric vehicles and electric vehicle charging in buildings. We're going to cover off, I guess, 4 main points. A bit of an introduction to us and our work. We're going to talk about the fear, uncertainty and doubt factor, which we're seeing quite a lot of, not just here in Australia, but globally. We're going to talk about this from an emergency response perspective, and myself and about half of our team are also operational firefighters, so we kind of come at this from a couple of angles. And then a quick look at the, all of that will give you kind of that background information as to how this piece of work was actually developed. Now, because it's a big group and we've only got an hour, we won't take kind of answer questions live this morning, but we really do want your questions and your thoughts and any solutions, any ideas that you have. We're going to collate a big list of them and answer as many as we can, and actually put them on publish them to the website. So if you can put any comments into the Q&A, into the chat, the team and I will collate those at the end of the webinar. So EV FireSafe has I guess, an aim to enhance emergency responder safety at electric vehicle incidents. So we want to, we of course want to support the transition to electrified transport in all its forms. However, we have to support a safe transition, particularly for our emergency response community. So that's where we sit. The ABCB advisory notice, which is, of course, why you're all here, hopefully you've all had a chance to have a look at this document. And as I say, at the end, I'm going to talk about it briefly, but the whole presentation I'm giving you will hopefully give you that background information as to how we've built our report that's that was commissioned by the Building Code Board and that has led to this particular piece of this advisory notice. So EV FireSafe is a private Australian company. We're funded by the Department of Defence to research electric vehicle battery fires and emergency response. In particular, we were looking at electric vehicle battery fires that occur while the vehicle's connected to energised charging. Now, as emergency responders, an electric vehicle battery fire is a challenge. When it's connected to energised charging, it adds another layer of risk that we're still trying to get our heads around, I guess. So part of the reason we're funded by Defence was this is a great Australian success story. This is the Bushmaster. I'll just play that quickly again. It was originally built in Bendigo in Victoria, and it's been electrified by an awesome Australian company called 3ME up in Newcastle in New South Wales. Since we started, we've been working with a number of, we've kind of become part of an amazing global network of experts and peak bodies and fire agencies and road rescue agencies that you can see here on the screen. Also some of the vehicle manufacturers themselves. And then I've been invited to join the technical panel for the National Fire Protection Association's 2-year testing program through their Fire Protection Research Foundation. So lots of acronyms and long names, where we'll be assessing electric vehicle firefighting techniques. How do we actually manage an electric vehicle battery fire? So the core of what we do is here. This is our database. So what we do is we look for particularly passenger electric vehicle battery fire incidents. and we collate that information. This is the work that Ciara does day in, day out. We capture as much information as we possibly can. Now, this feeds into a separate spreadsheet where we can manipulate the data. We can have a look at things such as, sorry, let me play that. We can have a look at things such as what worked, what didn't, how many litres of water we used, how many firefighters were needed for particular things. All of that information, all of that information is published regularly to our website, and I'm sure most of you will have seen it because you're on the call today. That's where we advertise the webinar. There's lots of information on here. It's aimed at emergency responders, but of course the information is hopefully broken down from very complex to simple information that can be easy for anyone to understand. Now, what we do day in, day out is this. We look at an incident, we gather information on an incident, and we're trying to determine whether that electric vehicle actually encountered a battery fire. So we're talking here about a lithium-ion battery, the high voltage battery that sits underneath the passenger vehicle. Now, as you can see on the left, I'll just move this along one. On the left here, we actually have a Mini that went into what we call thermal runaway or battery fire in Germany. I believe this was last year. This is clearly a battery fire. So we verified this information to say that, yes, the battery in this particular incident went into thermal runaway. We definitely had a battery fire. The incident on the right is a Tesla Model S fully involved in fire, as you can see. But even though you can see the amount of flame around this vehicle, the battery in this particular vehicle wasn't on fire. The high voltage lithium-ion battery in this car wasn't actually involved. Oops. Now, this is really important because when we talk about an electric vehicle fire, we can talk about an electric vehicle can be on fire but not involve that high voltage battery. Now, this is something we've known for many years, but it's only recently that we've been able to verify it with actual data. So our friends in the Netherlands, who do a great job of tracking their electric vehicle and lithium-ion battery data, found that in 2022, of all the electric vehicle fires that occurred in the Netherlands, only 38% actually involved the high voltage battery. So it's a really important point that an electric vehicle fire does not necessarily mean an electric vehicle battery fire. Now, this is important for emergency responders because it will change the way that we actually manage that incident. So I want to touch briefly on the fear, uncertainty and doubt. We're seeing a lot of this, particularly around social media, Facebook, if you're so inclined, TikTok, and anywhere. Electric vehicles are literally a hot topic, no pun intended. So what I want to point out is that people make money from making everybody else believe that these things, that electric vehicles are incredibly dangerous, that they're happening every single day. Now, this particular YouTuber actually did get in touch with us to talk about electric vehicle fires. But I don't think I guess our information wasn't interesting enough for them, or maybe our stats weren't high enough for them. They didn't really use a lot of our information, but they've had 1.6 million views to this particular video from which they make money. Similarly, this gentleman is an Australian car reviewer. He has sponsors for his YouTube channel, 45,000 views on this particular video. Actually, he was talking about information that we have been able to verify that was actually inaccurate. Some of what he was talking about is this. Now, these statements were widely reported in the Australian media. One of them talks about no personal protective clothing can protect us from the off-gassing or the chemicals of an electric vehicle or a lithium-ion battery fire, something that recent testing has proven to be incorrect. He also talked about 2 firefighters being permanently disabled following an electric vehicle battery fire. Now, we haven't been able to verify this. We've reached out to the person that made these statements. We've had no response, but we can say that we haven't had an electric vehicle battery fire in Victoria in a plug-in electric vehicle, and we certainly cannot verify with either fire agency that 2 firefighters have been permanently disabled as a result. So what do our stats say? So currently we have 389 verified passenger electric vehicle battery fires globally since 2010. All of our stats are global from 2010. That's when we were able to verify the very first incident. So 389 battery fires globally since 2010. The current global stock of plug-in electric vehicles actually is getting closer to about 22 million. The 16 million is back in from January, but we were unable to get stats for this particular month. Now, 389 might seem low, and it will be. We won't have captured everything. However, the 389 is I guess a data set, a sample data set, that where we can say, as I said before, these are verified incidents. They definitely happened. They definitely involve that high voltage battery, lithium-ion battery that sits underneath the vehicle. And they definitely, they absolutely needed an extended or different emergency response for the fire departments dealing with them. This is what it looks like year on year. Now, we saw a spike in the number of passenger electric vehicle battery fires through 2021 and 22, primarily due to the 2 cars that you see on the screen. So both of these had batteries supplied by LG Chem. Those batteries actually had a fault during the manufacture, so they were recalled, but in the meantime, they caused quite a spike in the number of electric vehicle battery fires. Currently, as of today, we're sitting at 40 verified passenger electric vehicle battery fires for 2023. That will fluctuate. It's not uncommon for us to find something that happened 2 years ago and be able to verify it, or we may have a battery fire on our investigating list that turns out that it wasn't. So these numbers do fluctuate somewhat, but this is where they currently sit today. This is what it looks like by manufacturer, and Tesla are right up the top there for a couple of reasons. The first being of the roughly 100,000 electric vehicles on the road in Australia, around 80 to 85,000 of those are actually Teslas. So they're the early movers in the space, the early adopters. They have more electric vehicles on the road than any other single manufacturer, and not just here in Australia, but globally. And as a Tesla Model 3 driver myself, I love the instant torque, the acceleration you get, but unfortunately that does sometimes bring people undone. And that instant torque and that speed is a common theme through our research, that people have had a collision as a result of speeding or that fast, rapid acceleration off the line. The other thing we look for is the cause of battery cell abuse. So the lithium-ion batteries that sit inside the battery pack, we look for what caused the abuse to the battery that led to what's called thermal runaway and fire. And I'm going to talk about thermal runaway in a sec. So primarily we're looking at collision. That's probably no surprise. Things like submersion are starting to come to the top. As climate change worsens, we're seeing more extreme weather events, more flooding. Hurricane Ian in Florida in September last year actually led to 17 verified passenger electric vehicle battery fires. We know of one from recent flooding in Italy. So submersion is certainly up there as a cause. External fire, I've highlighted this one because this is where most of our Australian incidents have occurred. But by external fire, we mean that the car was parked in a building or a structure, and the structure or the building burnt down around the car, taking the car with it and causing a battery fire. So on that note, just as a bit of a quick look, in Australia as of today, we've had 4 production electric vehicle battery fires, 4 verified battery fires that we can point to. All of them involve Teslas for the reasons I mentioned before. They're simply the most common electric vehicle, most popular electric vehicle here in Australia. One was arson, and the other 2 were actually external fires. So in both occurred in New South Wales. The first one was a single Tesla Model 3 in a garage. The second one was actually 2 Teslas and a Prius in a garage, and the building, as you can see, burnt down around the vehicles. So, as I hinted at before, the fear, uncertainty and doubt it seems very prevalent at the moment, and we've seen a real ramp up in this in the last few months. And we do have some concerns that the information isn't quite accurate. So from the 1st of January, we actually started to track all electric vehicle types, not just passenger electric vehicles. So here's basically anything on wheels. And any lithium-ion battery on wheels is what we were looking for. So passenger electric vehicles, as you can see here, as I said before, we've got 40 confirmed or verified battery fires globally for 2023. We do have 2 electric buses and 1 electric truck that we've been able to verify were involved in lithium-ion battery fires. Now, we also brought on board another firefighter who's our light electric vehicle specialist, or we're getting her on board at the moment. In the meantime, we've been tracking the number of light electric vehicle battery fires. Now, we would need 10 researchers full-time to track this particular sector because they are so prevalent. So what we've done is we've just tried to capture the incidents where a light electric vehicle, an e-bike, e-scooter, e-skateboard, a unicycle, hoverboard, those kinds of single-person mobility devices, where they've caused property loss, damage, or an injury or a fatality. Now, as you can see from the 200 plus, it's very difficult to capture absolutely everything because they happen so often. But what we can say is that we have 138 confirmed injuries and 32 fatalities. And what I want to point out is just in this past week, in the past 7 days, we have lost 2 whole families to an electric bike battery fire. One family of 7 in Cuba about 5 days ago, and a mother and her 2 children in the UK about 3 days ago, due to fires caused by electric bikes in both cases, privately owned electric bikes. Why is this the case? So when we talk about a road registered electric vehicle, a car, a bus, a truck, what we're looking at is very high quality, sophisticated technology that's been through a lot of testing, a lot of certification before it's allowed to be sold on the open market to the consumer. Typically, in pretty much all these cases, the battery packs are very well protected. They only suffer low wear and tear. And usually these vehicle types are parked outside or away from structures, i.e. on the road, on the driveway, those kinds of things. But when we talk about light electric vehicles, our e-bikes, e-scooters, e-skateboards, they're often a poorly constructed battery because there's such this massive push towards decarbonisation. Often they're poorly constructed cells and BMS, or battery management systems. There are no standards or regulations governing the quality or the safety of these particular items. They take a lot of wear and tear in daily use. If you think about it, an e-scooter, the battery pack typically sits underneath the deck where you stand, that gets kicked up and down curbs, that kind of thing. And then people bring those items into their home to charge, store, or use them. So when we have a fire in one of these more poor quality battery cells in one of the light electric vehicles, often the fire spread is much greater because it's already inside a home around combustibles. But this is a really important point. We can't conflate a high quality product like an electric car with a often lower quality products like an electric bike, a light electric vehicle. Now, I don't want to demonize that entire sector. There are some excellent light electric vehicles out there, excellent e-bikes, e-scooters that come from reputable suppliers. But in 2023 alone, it's estimated that 40 million of these units will be sold globally. And what we know is that often when they're privately owned, they're being bought online. And as I said before, there's no regulation, no standards around those. Now, in order to assist us kind of manage all of this, and also to, by extension, assist particularly fire, but also emergency agencies to familiarise with lithium-ion batteries of every type in every application, we've categorised everything here based on our research and the data that's coming through from our friends globally. What we have is currently 5 categories. And again, this is fluid. This will change as more ways to use lithium-ion batteries kind of come to market. But what we currently have is our smaller devices. That does include things like e-cigarettes, so vapes. We are seeing some increased number of incidents, particularly with vapes, again, particularly the disposable ones. Our light electric vehicle sector, again, highlighted because this is our highest risk. We're starting to see what we're terming light delivery electric vehicles. So if you think of kind of like a electric tuk-tuk or a side-by-side all-terrain vehicle that are being used more and more for very short delivery kind of jobs. We have seen a few battery fires in these particular vehicles that we're cautiously watching to ensure that to see how that sector goes. And then, as I said before, road registered electric vehicles, battery energy storage systems, we believe they're very low risk, but of course, when they do occur, they can be a high consequence. But in those two, particularly with our road registered electric vehicles, sorry, I should explain the terminology here. So ERG is Emergency Response Guide. It's a document from the manufacturer of that particular product that tells emergency responders, what do we do about this particular incident? What are we looking at? How should we manage it? Should it catch fire? How should we manage post-incident? How do we hand it over to, let's say, a tow truck driver, for instance? So in passenger cars, emergency response guides are typically available, which is fantastic. In some of the road registered vehicles, in buses, for instance, and trucks, where we do have some gaps in the emergency response guides. Similarly, in the BESS space, we do have some emergency response guides, some emergency response guidance coming through to us, but there's still some work to do there as well. So I want to touch now on why emergency responders are concerned about electrified transport across all of those types that you've just seen. But I'm going to focus on passenger electric vehicles again, simply because that's the core of our research. So as I said before, half our team are also operational firefighters, myself included, and how I originally got into this was I accidentally burnt my first electric vehicle in a bushfire, which is a story for another time. But we have some, while passenger electric vehicle battery fires are currently very rare, we have some new risks and challenges that we're facing into as emergency responders. And these are not well understood yet. To a large extent, the technology is leapfrogging our ability to understand and get to grips with what we need to know and what we need to learn, what we need to train emergency responders in. So we have a number of hazards and risks that are, some are similar, some are different to what we're used to, that you can see on the screen here. The other thing to note is that globally, not just here in Australia, not just in New Zealand, there are the training is kind of ad hoc at the moment. There's no kind of established training course for this kind of thing for emergency responders. And no agency in the world has published what we call SOPs, standard operating procedures. So a bit of a step-by-step guide on what to do should we be called to an incident involving an electric vehicle. Now, what we talk to emergency responders about is this is made a little simpler for us when we understand two basic concepts about electric vehicles and lithium-ion batteries. The first is, how is the battery pack constructed for an electric vehicle? And the second is this idea of this concept of thermal runaway. So I'm going to touch on both of these now. So inside an electric vehicle, we have lithium-ion battery cells. Multiple cells make a module, and multiple modules make a pack. And look, this is a simplified version. It will change depending on make and model. But as you can see here on the right, the modules along the side and along the top here form a pack in this exploded view. The battery management system is this little box right at the top here. And all of these things are the cells themselves are encased in protective metals to form the module, and then the modules themselves are encased in further protective metals to around the modules themselves. So all of this sits underneath the vehicle. In passenger electric vehicles, the batteries are always down low. So typically in full electric vehicles, they're between the chassis rails, between the four wheels, underneath the vehicle. In some of our plug-in hybrids, it may be further towards the back, maybe under the boot space, that kind of thing. But in all passenger electric vehicles currently on the market, this is typically where the battery pack sits underneath here. And we've kind of got three very basic, high voltage parts to an electric vehicle. A high voltage battery pack, the components, things like our electric motor, and then the high voltage cables that connect everything up and give the vehicle momentum. Just a quick note that all these systems, these high voltage systems, are DC, direct current. And anything orange in a vehicle indicates a high voltage of 60 volts DC or over, but your average electric vehicle is running at anywhere from 400 volts upwards usually. Now, thermal runaway is how electric vehicle battery fires start, but we're no longer really dealing with a fire that we're used to. As fires, we're used to putting the wet stuff on the red stuff, but with lithium-ion batteries, it's a bit of a different kind of concept that we need to get our heads around. So in this video, we have a little module of 12 individual lithium-ion battery cells, and they're being deliberately overheated under a thermal imaging camera so we can see what's going on. So I'm going to play this and kind of talk through it. So the first cell here is actually a heating cell that's heating up in order to abuse the batteries around it, the scientific term for battery abuse. As you can see, the first couple of cells have now burst. They're off-gassing, they're igniting. Then the next one goes. There's another one that's gone. In a second, another one will go. And bearing in mind that this is 12 battery cells in this little module here that we're seeing. So here goes, another one's heating up at the moment, ready to kind of burst. There it goes there. So this is the process of thermal runaway, but as I said before, it's not really a fire anymore. It's an unstable chemical process. It's exothermic. It generates heat. And roughly, this is what's happening. So if you imagine these battery cells are inside an electric vehicle, it's been involved in a collision, and one of these battery cells is crushed in the collision. So the battery cell short circuits and it starts to heat up. And once we kind of reach that sort of anywhere between kind of 60 to 70 degrees roughly, the heat becomes almost self-sustaining. At this point, the battery cell can't be cooled down again by the battery management system. So it starts to heat up, the pressure inside the cell starts to build up. And eventually when we reach roughly, again, very roughly 170 degrees, the battery cell will actually burst. The pressure becomes too much, the cell bursts, and when it does, it releases toxic flammable gases. Now, these are often described as smoke, but actually what we're looking at here is a couple of toxic flammable vapor clouds, and I'll talk about that in a sec as well. Now, it is possible for a lithium-ion battery at this point to just off gas, but of course we were only looking at the ones that actually ignite. So at this point, what can happen is that the gases ignite, and then the heat that's being generated by this one cell is then dissipating to the next cell, and the next cell follows that same process. And then the cell next to that heats up and follows that same process. And we get this kind of domino effect, this thermal runaway effect. Now, that's, as you saw before with the module of 12 cells, you saw how that kind of happened under the thermal imaging camera. But if you imagine that the Tesla Model 3 that I drive has about 7,000 of these cells, suddenly you kind of start to see the challenge, if this occurs, the challenge for firefighters when we start to talk about 7,000 of these cells potentially following this same process of thermal runaway. Now, as you saw before, the battery pack sits underneath the vehicle. And we as emergency responders, if we're turning out to an incident involving an electric vehicle, that battery pack's underneath the vehicle. It's encased in all those protective layers of metal. So we can't see what's going on inside that pack. But there are some early warning signs that we can pay attention to give us the clue that this battery may be about to go into thermal runaway and that fire is imminent. So the first sign is a popping noise. So it's a very loud popping noise. It's often described as gunshots. That's the noise of the battery cells bursting. We hear a hissing or whistling noise, which is the noise of the gases venting out of the battery cells. There's a sweet kind of electrical smell. Our American colleagues who apparently like to spend their time sniffing this stuff describe it as cherry bubblegum. We'll start to see bits of cell become projectile from underneath the vehicle as the cells burst. And then, as I said before, we then see two vapor cloud types typically. And it's often described as smoke, but it's not. So we have a dark vapor cloud of heavy metals from the cathode of the battery pack. And then we have a lighter vapor cloud that are primarily hydrogens. Now, if we're going to see flame, at this point, what will typically occur is we'll see an ignition of those gases. But in a very small number of cases, we've actually seen the gases build up and deflagrate or explode. So I'm going to show you an example of both of those. And I want you to bear in mind that while we watch through this, again, the context is that these are still very rare. So I'm not sure if we got volume on that, Dan. Can you guys hear that?
Not at this stage, no, sorry.
Okay, all right. So I'll link this video out. Sorry, Teams always seems to trick me as to whether or not it's going to play volume or not. But with this particular van, it's an electric van charging. This incident occurred in China. There's a popping, hissing, whistling noise, and we start to see the dark vapor cloud appear at the bottom of the van itself here. We'll see a lighter vapor cloud just appearing at the top there. So ignition has now occurred. And then this is the really important point here. We've got gases escaping from the battery pack underneath the electric vehicle. They're escaping in a direction. Typically, it's because there's a vent, a designed vent, or maybe a breach in the battery pack itself. So the gases escape out of that particular vent or hole. They're ignited. So what happens is they form a blowtorch effect, a jet-like flame, directional jet-like flame. But the challenge for emergency responders is we don't know where around the vehicle that directional jet-like flame could appear from. It depends on how the battery pack was originally abused or damaged. So if you imagine emergency responders working around this vehicle, perhaps to extricate occupants, we have these early warning signs, but it can happen. Thermal runaway can lead to fire very, very quickly. So this is the concern, the challenge that we as emergency responders have. Now, vapor cloud explosion, as I said before, occurs very rarely. We've been able to, in passenger electric vehicles, we've been able to verify 16 globally since 2010. And of course, for obvious reasons, they typically occur in an enclosed or underground space because the gases have nowhere to vent to. They kind of build up and to the point that they explode. Now, this particular, oh, sorry, let me go back a quick step. So I just wanted to point out that globally since 2010, we've been able to verify 4 incidents of vapor cloud explosion in an enclosed space while the vehicle was connected to energized charging in passenger electric vehicles. Now, this incident occurred in April. I'll play it a couple of times because it's a quick little video, but inside this private garage here is a hybrid, a plug-in hybrid electric vehicle that went into thermal runaway. Let me play that again. At the time of this explosion, it actually, as you can see, it blew the garage door off. There were 3 firefighters inside the garage actually putting water onto the vehicle. And the firefighter that at the start there actually had his helmet knocked off by the door, so had a very close call. Now, nobody was injured in this particular incident, which was, but obviously very, very near miss. So the other big challenge for the emergency response community is we're still working out what's the same about an electric vehicle battery fire compared to the internal combustion engine fires that we've been dealing with for decades, and we're still working out what that is. And we talk very often, very frequently with our colleagues in Europe, particularly the RISE Institute, ENFPA, National Fire Protection, National Fire Chiefs Council, our friends at the Institute of Public Safety in the Netherlands. Anyway, the list goes on, who are doing the testing around this. So we were recently in Europe to attend a number of conferences, and currently, at the moment, this is what we can say about the similarities and the differences between an electric and let's just say an internal combustion engine vehicle. So recent testing from RISE indicates that we have a similar heat release rate, so HRR, heat release rate, a similar heat release rate between the 2 vehicle types. We have toxic air, we have toxic gases and smoke coming from both vehicle types. We used to think that the temperature from a lithium-ion battery fire was significantly higher, maybe double to 2.5 times higher than a petrol or diesel car. RISE have tested that now at about 1200 degrees compared to about 1000 degrees for internal combustion. But of course, the big difference is that given the thermal runaway kind of process that we showed you before, we typically have a longer incident duration, and essentially an electric vehicle battery fire, we never really extinguish it. We kind of bring it under control, but we always have to continue to monitor for it. So we have this longer incident duration. Typically, very rough rule of thumb from our data is firefighters can expect to be on scene for roughly 3 to 5 hours, compared to maybe 30 to 60 minutes for an internal combustion engine fire. The fuel source is, of course, also different. So in an electric vehicle, the fire is fueled by the lithium-ion battery, and in a petrol or diesel car, it's fueled by the actual fuel tank, typically. The other big difference, as you saw before, is that with the battery fire, electric vehicle battery fire, we have flames down low, that directional jet-like flame. With all other cars, we kind of get a 360. It will just burn all around the car. Now, we've only got one real-world case study that actually compares the two. Now, an arsonist in 2022 in the Netherlands shouldn't say it, I don't mean to be flippant, but very kindly set fire to 2 types of vehicle, a petrol car and an electric vehicle, in the same car parking garage at the same time, or and one after the other. So it's given the first, given researchers like us, the first opportunity to kind of compare things side by side. And we're currently getting more data and more images from this particular incident, including the concrete spalling on the ground. We don't have all of those images just yet. But what we have on the left is a petrol Citroen. On the right is a fully electric Ioniq. And this is the difference in concrete spalling on the ceiling following this incident. So it's the first opportunity, I guess, to have a look at that real world incident and start being able to make some comparisons. Now, we make these cautiously because we don't know how full the fuel tank was on the petrol car. We don't know what the state of charge was on the electric vehicle. But it does give us, again, a bit of a starting point to have a look at this. And the other big challenge for emergency responders is there's no, I guess, silver bullet yet for suppressing an electric vehicle battery fire. And as I said before, realistically, we've started to move away from the word extinguish. We can, when we have an electric vehicle battery fire, the only point that the incident is really over is when that battery has been completely scrapped. So it's been turned into black mass, or shredded by waste recovery. Up until that point, we need to be alert and alarmed once an electric vehicle battery has been involved in some kind of incident, and I'll explain that a bit more in a sec. The globally recognised methods at the moment are really cool, burn, or submerge. So when we talk about cool, we are taking a hose stream and putting it on the underside of the electric vehicle and trying to dissipate the heat that's being that's being generated through thermal runaway. Dissipate that heat through the water rather than letting it propagate, the heat dissipating from cell to cell and that thermal runaway process continuing. So we can, by cooling the battery with a stream of water, we can start to suck some of that heat out of the battery and eventually slow and hopefully control that process of thermal runaway. But we often talk about it, it's like us turning up in a big red truck. Someone's reported their kitchen stove is on fire, but we put water on the outside wall of the house in order to put out a kitchen stove fire. So that process can take a very long time because we're not really getting the water to where we need it to be. And of course, it will use a lot of water as well. We can let the battery burn out. And I'm an operational firefighter with a rural brigade here in Victoria. This is a valid option for us. If we have an electric vehicle battery fire, out in a rural area where it's not going to impact nearby residents, and we don't need to, perhaps we don't have the water that we need in order to actually cool it, we can actually just let that battery burn out completely. And there's a number of reasons why this is a good option. It goes against the grain for us as firefighters not to, be, run a hose and get some water out, but we can actually just let these battery packs burn out. Submersion is used with great effect in some parts of Europe, particularly in the Netherlands. We spent some time with our colleagues there, as I say, recently. They actually have a fantastic system of 30 submersion containers located around the country. They're deployed upon report of an electric vehicle incident. Any incident doesn't need to involve the battery. And the vehicle is put into the submersion container. It may be dry transported back to a site for monitoring, or if there's an active battery fire, they may fill it with water. So that system works really well in the Netherlands, but it's not, submersion is not recommended by all EV manufacturers because we have to, it makes it difficult to monitor the battery once the vehicle's in the water. And if we pull the vehicle out of the water too quickly, we can actually reignite that fire. We can have a secondary ignition. So as a quick look at it, this is what our colleagues in America do. They'll actually jack up one side of the car, but of course, having a firefighter this close to an electric vehicle where we potentially have a jet-like flame is not something we're super comfortable with, but it's an option, as I say. This incident occurred in Berlin, just outside Berlin, sorry. There was no impact on nearby residences. So the car was on its wheels when the fire brigade arrived, but they actually flipped it so they could watch the battery burn. And then this incident, again, this is one of the Netherlands incidents. So you can see here the submersion container arrives on the back of the truck. The vehicle is craned into it, and this was actually dry transported. It was strapped down and dry transported to a site where it could be monitored. And just to give you another quick look, just look under the water here. These are e-scooter lithium-ion battery packs that were put into what we call a collar tank following a warehouse, an e-scooter, e-bike warehouse fire in the UK. You can just see there the flames actually underneath the water itself. So again, just another quick look at the challenges that we're facing with this. Now, I mentioned a couple of times before secondary ignition. So according to our research, it occurs around 10% of cases. So I'm sorry, let me go back a step. So 10% of the passenger electric vehicle battery fires we researched experienced a second ignition, and in some cases multiple ignitions. So in one particular case, we saw 4 separate ignitions of the battery pack over a 48-hour period. In a second incident, a second ignition occurred 68 days after the initial battery pack fire. So it is something that, as I said before, we do need to, we can, in theory, you can never really extinguish this battery fire. We can suppress it, and then we need to monitor it. So the reason this happens is this. So Dan was gifted a burnt e-scooter battery pack recently. He actually submerged it in water for 3 months, then pulled it out and measured the voltage on this cell that you see here. Now this cell's measuring 3.69 volts. Now at full capacity, at full state of charge, it would only be at 4.2 volts. So even after being burnt and then submerged in, it was fresh water for 3 months, these cells are still what we call live. So they still contain energy, which means they can still go into thermal runaway. So while some of the cells have burnt through in the initial incident, we still have these damaged battery cells that are still holding power. So this is why we can sometimes see that secondary ignition. And we see it more commonly in the light electric vehicle space, e-bikes, e-scooters, again, because of sometimes in a lot of cases, the battery cells are not as well constructed as we see in road registered vehicles. Now, there are some emerging products, and I'm going to show these because otherwise we will get asked the question about fire blankets, F500 extinguishing agents, those kinds of things. It's great that everybody is coming together to try and find some solutions and innovate and build product, but at the moment, we don't recommend the use of any of these because there hasn't been enough testing. Because some of these are coming to market with, I guess, no standards and as I said before, very little testing. And in some cases, we may actually increase the risk to emergency responders by the use of some of these products. So if I don't want to pick on anyone and I don't want to stifle innovation. This is really good, but we do need to ensure that if we're going to recommend a product, that it's actually going to work and keep everybody safer. But if we take the example of a fire blanket, the point of the fire blanket is to put it over an electric vehicle. And some manufacturers will use the word, it will extinguish an EV battery fire. It won't. It's not cooling anything underneath that blanket. So thermal runaway is still occurring under there and the gases are building up. And in a couple of testing examples that we've seen, someone's picked up a corner of that fire blanket. The inrush of air has actually caused a vapor cloud explosion. So these are great, but as I say, we don't recommend at this time anyone rushes out to buy these products because we simply can't say with any confidence that this is going to decrease your risk. So charging, sorry, I'm running out of time here, so I'll crack on a bit. So our data indicates that in passenger electric vehicle battery fires, approximately 18% occurred while the vehicle was connected to energised charging. We're starting to be able to benchmark this against stats from other countries, and it ranges from about 18 to about 25%. So we're pretty comfortable with the numbers. When we talk about charging, we've got 3 different levels. So our portable, what we call a granny charger, our level 2, mode 3. So the AC, the slow chargers that typically you'd have in your home garage, right through to the big guns, the DC chargers that will fill a car very quickly, an electric vehicle very quickly. From what we've been able to verify, and of course, bear in mind that it's difficult. We may hear that a car was charging, but we may not be able to get any more information on that. But from what we're able to determine, so it's roughly 74 that were connected to energised charging. Sorry, that should say 18%, not 19. 31 were connected to charging in an enclosed space. And as I said before, 4 of those then led to a vapor cloud explosion. Now, again, these are globally since 2010. These are the verified incidents that we've been able to find globally since 2010. Where we could break that down even further, here's what we found. So 6 were connected to the granny charger, the portable cable, 16 to AC and 11 to DC. Now this surprised us because when you charge DC, obviously the battery heats up a bit more. We always assumed that DC charging we'd see more battery fires with DC charging. But I guess the working theory at the moment is that you're just connected to an AC charger for a longer period. Now, we're still trying to verify or break down the stats even further to say, of these incidents, how many actually involved vehicles that had previously had some battery abuse. So, for instance, a vehicle that had been in a flood, Hurricane Ian in Florida, there were a number of cars that were in private garages. Floodwaters came through, submerged the vehicle for a number of days. But the vehicle had been left connected to charging, but the grid went down, the power went down at the start of the hurricane. Then once floodwaters had subsided, the grid power went back up, and then that kick of power into an already damaged electric vehicle battery then led to a battery fire. So we're trying to break that down even further into what are some of the circumstances behind these charger-connected battery fires as well. So the risk to responders, when we start talking about EV battery fires, where we've got a fire, isn't the main risk of electrocution, I guess, is not from putting water onto the vehicle itself. As I said before, they're DC systems. We can't become the earth with that. We can't. So if we put water into a down power line, we run the risk of being electrocuted through the stream of water, which is conductive, and we become the earth with AC grid power. With electric vehicles, because they're DC, very, very low risk of electrocution. We have no instances or even near misses of electrocution in this circumstance from the research we've done. However, when we put charging into the mix, which is fed by AC grid power, we do have a slightly increased risk of electrocution. So now that we know this, now that we know that we have roughly 20% of our incidents occur while the vehicle's connected to charging, we have this slightly increased risk of electrocution because of that charging infrastructure involvement. Sorry, that's just a slide to say what we would typically do about it. We'd cut the power from upstream, typically at distribution board. That's what we do with any large electrical appliance that we're dealing with. But now that we have this information, this data, then we can start to build a bit more safety into our charging sites. Hence the ABCB advisory notice. I know you were wondering when the hell I'd get to it, so here it is. So this report that we were commissioned to write for the Building Code Board last September is on the website. Some of you may have had a look at it already, but essentially what this report does is takes everything I've just said to you, puts it into a report and spits out at the end some foundational guidance some foundational guidance that we can provide to charging site owners, to charging site installers, the suppliers, everybody that's involved in this sector, which, let's face it, will be everyone over the next 20 years as the transition to electrified transport continues. Some foundational considerations and guidance to keep everybody safer, but primarily emergency responders attending incidents involving EVs and charging. There it is there. Maybe someone can put it in a link to in the chat for me as well. But the report is broken into 3 streams that have led to the 15 pieces of guidance there. Thank you, whoever's just put that in the chat. And they sit under these kind of broad themes of safer charging environment and safer people. Now, I won't go through everything point by point. Suffice to say that in particular, if you're a site rolling in charging, you're concerned about this issue, please, the Electric Vehicle Council have just published a page on their website that talks about what you should do in order to make everything safer in accordance with this advisory notice, and bring your emergency responders along for the ride. Consult them, bring them to the site, show them where you've put charging in, show them maybe where you're putting battery energy storage systems in. Nobody has all the answers on this yet. Not us, nobody globally has all the answers on this yet. And I'm the first to admit that this isn't perfect, but it's a start. It's a starting point from which we start to build far safer charging sites for electrified transport, and therefore far safer buildings and people. So as a really quick look, our safer charging stream enables responders to shut charging down quickly and effectively, meaning we can act and respond to a fire far quicker by being able to spray water around. The safer environment assists us by giving us easier access to these sites and assist people to egress those sites if they need to. And then, as I said, the safer people side assists responders through familiarisation. So ESIP is an emergency services information pack. That's the terminology that Fire Rescue New South Wales use. They have an excellent page on their website that talks about what should be in an ESIP. PIP is a pre-incident plan, so it's something that we may carry in the truck, maybe a bit of paper that says this site has, here's the security guy's number, so if we're attending after hours, we can call that person and make sure that the gate's open for us, those kinds of things. And of course, all of those should include block plans that tell us where is the charging located. So if you take, for instance, a shopping centre site with multiple entrances, which one should we be entering in order to reach the charging site the most quickly and effectively? So hopefully, sorry, and just as a kind of finishing statement, the advisory note is foundational, as I said, but we wanted to provide, in these early days of this transition and the rollout of electric vehicle charging, low cost and low impact, just sensible considerations, while collectively, globally, we continue to the research, the testing, while everything in that space matures. We just wanted to, we wanted to be able to start somewhere to build from. And we believe that Australia's taken the lead here, and massive thanks to Gary Rake and his team for actually, kind of being the first to it's always difficult being the first to do something. So being the first to put this out there, and I'm sure that other countries, I know that other countries are following what's going on here and how this process will work, which again circles me back to, please continue to put your questions in the Q&A or the chat, because we do want to be able to have a look at any solutions that people might have for some of these things, some ideas where we can improve, where maybe we haven't done well enough. So I think I'm finishing just on time. Oh no, I'm not. I've got a few more quick slides. For EV FireSafe ourselves, we're working with the various agencies and people and federal government to develop emergency responder training. These are the priorities as we see them. As I said before, where EV battery fires are very rare, but we are seeing electric vehicles involved in collisions on a regular basis. So how do emergency responders actually safely manage EVs involved in collisions? We're establishing a global webinar series, so we want to get all our colleagues from around the world together in the same platform and actually talk through incidents that have occurred, whether they're on an electric ferry, an electric bus, trucks, cars, battery energy storage systems, whatever it might be. We want to move the conversation a little bit away from here's what we think and here's all the stuff we don't know to here's the incident that occurred, here's what worked, here's what didn't, here's what we change, here's what we've recommended for future best practice. And we've actually also established a second arm to the EV FireSafe company. We've established EV FireSafe for business. We're actually developing some training for the non-emergency sector off the back of some consultancy work with a large shopping centre client who was concerned. They were concerned about lithium-ion batteries in their shopping centres. So some familiarisation for everybody else that's not an emergency responder, in the hope that by sharing that information and knowledge, we can actually maybe start to bring down the number of incidents as well, that particularly the incidents that with our light electric vehicles that have been leading to so many fatalities. So thank you very much. Really appreciate your attention and your time, and as I said, really keen to hear your comments and your questions, and I will let you all get back on with your day, and I'll go take 5 minutes to have a little cup of coffee and calm the nerves again. But thank you very much, everybody, for joining us, and we'll hopefully hear from you very soon. Thank you. Bye.